Well, hi, good morning. Thank you so much for joining me in my shop here. Today is June 2. It's the second day of June. I've got company, as you can see already. I got hardly come in here. He spends a lot of time on my keyboards these days. What are you chewing on there? He's going after the power cord. Okay, so next thing to do now is to start replacing capacitors in the radio part of the radio, the RF part. And I think what I would want to do is try to identify any capacitor that has something to do with the screen circuit to start with. So screen circuits. So we will take a look at the schematic and see if we can find any of those guys. Can you please just move off the keyboard here, please? Thank you. Okay, so let's just take a look at which tubes here have screens in them. So it looks like there's screens in the output tubes, and a screen here, and here, and here. So is there another tube? Oh, now I got a cat in the way. Just, oh, how can I possibly do this kind of stuff? I can't even see my computer screen. It's all cat now. Let's do this. And then we will do this. Okay, there we go. Yeah, that's what I'm trying to work my computer through. Come on, man. You're wrecking the show here. Yeah, you. Come on down. Climb down from there. Okay, I can see my screen again. And get back to work here. Okay, back to this. So the screen circuit has to be handled in a very careful way in order for it to do its job, and part of that usually involves a large capacitor. There it is there, 0.1 on the screen circuit, and it's probably coming out of here is where it's coming. So now I think I may have changed this right off the bat. This may be the one that I changed, and it turned out it was completely defective, just coincidentally. So so this guy's been done. There's nothing else on the screen out here. If we come back to the audio circuits, which I should have dealt with already, what are they doing here with the screen? So there's the screen SG screen grid. Another one, come down here. So it has no special capacitor on it, and it's probably because this is an output tube and it's not so required here at this point. That's what I would suggest. Okay, so the screen thing's going nowhere. I've already done it. What would be next? Maybe we take a look at the well, we could just start right at the antenna and just work our way in. Why don't we do that? So, numerous antenna terminal connections here. Like I said before, A3 is for shortwave, and A12 is for a loop antenna, which I have not connected to the radio. I've been connecting a mini whip antenna to the radio. Here's an adjustable capacitor here. Here's one here, 15 picofarads. So, picofarad capacitors probably of the type that's really not important to change out. Not unless you really have a strong indication there's something afoot with it. There's another adjustable capacitor, and then here's the first one. So all the signal from the antenna after passing through this transformer arrangement and the switch, all of it goes through this capacitor to get into the rest of the radio. So if this guy's bad, everything's bad. Of course, the radio's working fairly well, so how bad can any of these really be? 0.01. Can we find this? So it's connected right to the grid cap circuit. So if we follow the grid cap wire down under, we'll probably find this capacitor. Okay, let's do that. That would be my back right there. Okay, first tube, a grid cap. So first tube is here, grid cap wire. comes right to here. And on there's the capacitor. I don't know if you can see that or not. Right down at the bottom at the chassis is a capacitor. I'm sure you cannot see it from there. So one lead is connected to the terminal with the wire on it, which is what we would expect, and the other terminal is connected to a terminal on the switch. Whoa, am I going to get down in there? Change that out? Let's just see what I can do before I do anything. Can I really get down in there? So, yeah, my fingers can barely get down there. So this terminal here is probably quite doable. Get the capacitor wire around there. Cut the original one. Even cutting it's very difficult. Getting cutters down in there, very difficult. Oh my gosh. Why'd they put it way down there? You know, there's another. No, there isn't. There's another one even worse. Some of the other capacitors that are buried down here are these black molded ones, which aren't particularly reliable either. That's the only one I see up there, so that's the only one we got to deal with. Look at this big guy. I forgot about him. Who's he? Hey, let's just leave that there for now, and I'm interested in this big one here, this big whopper, and it's going to the chassis and then down. Maybe this is the one I thought it was. It appears to go to a switch terminal and nowhere else. So that would be a capacitor to ground off of this switch. Yeah, there's nothing else on it. Wow, capacitor, a big capacitor to ground through a capacitor grounded on one end and goes to a switch on the other. Let's see if we can find that on the schematic. Okay, so first of all, is it this one? No. Well, one end goes to ground, the other end goes to a switch. Oh my gosh, and all by itself to a switch. Maybe we can start by looking at the switches and come out of there. No big capacitors here. Next switch, 0.01 picofarads, 0.01 picofarads. Anytime I say picofarads, what I'm really saying is probably a mica capacitor. Another set of switches. It's the band switch. Where else would the band switch be switching? Down in the down here. Switching down here in the picofarads. Oh, look at that. There he is. One side grounded, the other side right to... No, it's not going to a switch. Did I follow that right? And it's attached to a coil. This where's that capacitor? I don't think that's the one I just looked at. Oh my gosh. Or the other side. So one side grounded, the other side going to straight to a switch and nowhere else. Okay, well, keep. Must just double check all these and be absolutely sure. What are you doing back there, cat? Oh, I think he left. I don't think I have a parts list in this on here either. Well, that's kind of interesting. Can I see the size of the capacitor? Let me take a look at that. Often you can rotate the cardboard cover. And I can't. I think it's written right there. 0.25. Right there. 0.25. That really does. Oh, I followed the wrong wire. Okay, it doesn't go where I thought it went. It goes down to a tube pin. Ooh. Pretty scary stuff way back in there. Okay, so it's going to a pin on the second tube, I believe. This is the second tube. Is it? Maybe it's the first tube. Maybe I got a tube diagram. I can figure it out. Big capacitor comes down to. It's in the way. There we are. So it'll be 1, 2, 3. Looks like pin 3 comes down to. Let me count again. One, 2, 3, 4. Looks like pin 4. Big fat capacitor on pin 4. Pin 4. Now what tube is that? That is putting this the right way. This is looking down from the top. So I actually have to flip this over. So it's one of these two, and it's the one at the back. At the back is a 6J7. 6J7. Okay, we'll take a look at the schematic here. Tube 2. What? Where's the 6J7? I don't remember testing a 6J7. What happened there? I remember it being a 6K7. Maybe they're swappable. So there's definitely a 6J7 on this on this diagram, but on the schematic from the same page. Wait a minute, is that really true? What's going on here? So you look at this, you see 6J7 RF amp oscillator. Okay, this is the oscillator tube. They've written it right on there. So no, this is the first tube in the radio here, but this is the one we're interested in, 6J7. Again, it's down here, Jim. Okay, I'm okay again. Once again, reality is setting in. So off of this tube is that fat capacitor. Off one of the pins on the 6J7. I do not remember testing it. EF. Not that that means anything anymore. Okay, 6J7. And this capacitor is coming off of pin 4. Pin 4. Guess what? It's a screen. Pin 4 is a screen. So if we look here on the screen, right here, let me follow this. Didn't I do this? I did this already. Oh, look, we go this way. Up here. And we can encounter it. But this doesn't match the radio, really. Radio shows a grounded capacitor coming to a switch, and there's nothing else attached. What am I seeing here? No. That was what I thought earlier. Now I know better. It doesn't just go to a switch. I had that wrong. Okay. Now I really got my head straightened out. Of course, it's my head that thinks it, so who knows? So that's what that guy is. Now, what else is it? It's really involved in just the oscillator. Well, we're going to have to go and change that out. A big thing like that. Look where they snuck it, way off in the corner of the schematic. They're probably laughing when they wrote the schematic. You'll never find this. Well, I did find it. Not only is it hidden in the schematic, it's hidden in the radio up in here. Okay, let's cut that guy out. Funny how I started out saying we're going to work on screen capacitors, and I decided no, and now here I am working on a screen capacitor. Really dirty down in here. There's one wire I want to cut and a bunch I don't. There he is. Okay, we're going to give this guy a test. Dirty, dirty, dirty. Another 0.25 I have to find. And the screen circuits have high voltage on them. So it's got to be a good capacitor. Maybe I have to put a couple in to get up to this. 0.25. Now, I think screen circuits have a lot of current available, so a leak isn't all that critical. There we go. Oh my gosh, look at that. I can't believe it. 150. Oh my gosh, it's in great shape. Oh, it's in good as can be. Put it back in. That's a good one. I don't want to test it at a higher voltage. That's high enough what we just did there. Well, there you go. Even though it's old and ugly and dirty and hidden in the corner, it turns out that capacitor's doing its job. And that's why the radio is working fairly well. I think if that capacitor was a real dog, I think we would hear funny howls or something like that again. Well, I gotta find a 0.25. Yikes. Over the years while I've been doing this work, I've been kind of lucky quite a few times actually, and in this case I acquired the remnant stock from two different stereo shops, two different occasions, two different families, with remnants from their closed stereo shop. They had closed maybe a decade earlier or 15 years ago, and they were just cleaning out, and they found me and phoned me up and said, hey, we got some stuff here, would you like it? And I don't even know what I'm getting into. Off I go. Well, this is one of the things I got. I've never looked through this very carefully, although I did know I had a lot of fairly large capacitors in the big bucket here. These are all 200 volt capacitors, and there's stuff in here I could use. Like this one here is basically a 0.5. It's even bigger than the one that was in there. But they're 200 volt capacitors, and the one that came out of the radio is a 300 volt capacitor. And I don't know what the actual voltage is on a screen circuit, but in this radio, but it's typically 200, 250 volts. So I'm right on the edge of using one of these. But I thought, I looked at this, I don't think I've ever looked through this set of drawers. It's just been down on the floor here, buried under some other stuff. So I thought, well, let's have a look. So what we got here is a whole bunch of electrolytic capacitors. Because these were stereo shops, with modern equipment, these are all going to be low voltage. Like this is a 50 volt capacitor. So unfortunately, they don't have much opportunity to go into an old vintage radio. Hey, look at this. So these are pickups from tape recorders. That's interesting. Heavy diodes here. Oh, here's some more. A rectifier. Plus and minus. And a whole pile of diodes. Oh, these are little numbers. I've got the numbers. Oh, what are those? Those look like sensors of some sort. Like a light sensor. Not sure what those were. Okay, a whole bunch of capacitors here. I think this one's a double-ended capacitor, which means it's positive on both ends. Yeah, it says right, negative. It says NP. Oh no, I'm wrong. I guess I'm wrong about that. I'm wrong. I take it back. 25 volts. So these are getting all low voltage stuff. Oh, look at that. Output transistors galore. Look at that. 2N's 174. Hope you're having fun. Looking in my drawers here. Hey, do you need some diodes? What is this? This is going to be a 4000 series one, I think. 4007. Are they all 4007? Probably. 4007. 1N 4007. Hey, those are good. Don't forget they're in there. But, LEDs. A little teeny tiny one here. Never seen one that size. Okay. What are these? They look like a surface mount. 20, this is 25. This is the right size, but 100 volt again. Hasn't got the voltage range. Here's some more. These have come out of things. He's taken these out of stuff. It's got long leads on it. They look like they came out of stuff. Long leads again. Okay. Not going to be too useful to me. There's a whole pile of who knows what in there. Looks like little capacitors. Volts it says on it, but there's no way to capacitor in there. What do we got here? Got some clamps or something. And some transistor sockets here. Wow. And what is this stuff? Oh, these are little mica sheets. All kinds of them. And then all kinds of little spacers and insulators and everything under the sun there. It went that way. This one's backwards. We put it in there backwards. Because it's empty. Oh, it has no lip. So it's not actually backwards. It's broken off. Okay. Oh, these are a whole bunch more oh no. These are little IF transformers. Wow, okay, that's interesting. And some adjustable trimmer type capacitors. Again, all targeted towards small stereos. Okay, various output transformers. Hey, I might be able to use some of those. Variable resistor. It says 5K on it with a little adjuster on the top. And these are probably also variable resistors by the thousands. All kinds of them. These have come out of things. So whoever's doing it was stripping some of this stuff out. I hear my cat's just running around like crazy. Like crazy behind me. A bunch of more transistors. These are capacitors. Why so many? Capacitors here. These probably can sustain high voltage, but likewise here. chip of some sort. That's a big whopper there. Somebody needs that chip. Somebody in the world needs that chip. Oh, there's a whole bunch more of them. So these are probably germane to certain stereos. A whole bunch more. Well, these are the mostly the sockets here. And what do we have in the last one? Oh, a very interesting box full of exactly sure what that is, but I think it's just a wire with a thing on it. Oh, there's diodes in here. Why would we have diodes in here? Is that a diode? What is that? It's not a diode. It's a coil. That's a little tiny coil there. So these are all chokes of sorts, I guess. Look at this guy here. Some interesting stuff in there I could potentially use maybe someday. Maybe if I live to be 100. Okay. Well, what are we left with? Going through all that. Thank you for tolerating my review of the stuff I have. Can we put a 200 volt capacitor in there? I don't think we could put a 100 volt capacitor. I think we'd be playing with wildfire. But these look like pretty high quality capacitors. That one, this looks really expensive. Aerovox 200 volt. Pretty sure that's 0.33. This will be the one. Okay. I guess what we could do, it's too bad I didn't read the voltage before taking that capacitor out of there. Screens are usually a little bit less in voltage from the plate. Not always, but in most cases. You need the screen to be a little lower voltage than the plate. I also have these guys. They're also 200 volt. They don't look nearly as good. Okay, I think that's what I got to do. Too bad I took that capacitor out. You know, I should have hesitated, found a new one before I took the old one out. That might have been a better way to go. Okay, I'm going to put this in, and goodness knows where it came from in here, because I just cut it out and I didn't pay attention. Well, I got to remind myself. I did leave little wire tails in there to find. Okay, let's do that. Kind of hate to do it, but I think we need to read the voltage across the capacitor while the radio is operating, just to see if I didn't put a 200 capacitor into a 300 volt spot. Gosh, I can't get away with anything here anymore. What are you doing here now? Okay, so we're going to be reading a fairly high voltage. I'm going to do it right across the, well, the capacitor goes to the chassis, so that's not a problem. Clip lead, one lead to the chassis here. Oops. And that doesn't really matter either. I can take that off. Anybody listening to the radio last night? I turned on my radios last night, and nothing. Nothing. And because of the tremendous activity on the sun, I mean, I'm guessing you're paying attention to this. We were out last night looking for aurora, but we didn't see any. Here anyway, and I didn't stay up late enough. I'm only up till 11:30 or so, and then maybe in the middle of the night there was some aurora outside. But in any case, I turned on my shortwave radios, and what did I get? I got nothing. And the interesting thing is, the noise level is smooth, like very smooth. Usually the noise is doing this, right? It's usually popping around. And you hear it, you know, that crackly stuff and whatnot. But last night, I could tune anywhere on the radio, practically. Hear no stations, just very few. I got one from South America, oddly enough. Radio Amazonia, which I regularly can receive. That was coming through, and it was a very high frequency it was coming through on. I can't remember what it was. But in any case, the noise is smooth as could be. Why so quiet? And I realized what's really going on now is I'm hearing on my radios the local situation, local being hundreds of miles around here, but there's nothing being reflected to my location from elsewhere in the world, including noise. So once the atmosphere becomes non-reflective, the long-distance noise disappears, and you're left with the local stuff, which is almost nothing. There are no lightning storms in the area or anything like that. So is that what's really going on then? Under normal conditions, the atmosphere is reflective. And not only do you hear reflections of the distant radio stations, but you hear reflections of noise from anywhere in the world. Like there's noise everywhere. So anywhere where it can reflect to you, it is reflecting to you, and you're hearing it on your radio. I don't. That's what I think is going on. Okay, now let's get back to this. Okay, with the dim bulbs in place. There we go. Okay, the set is on. Now getting up here with a voltmeter is a little bit crazy. Stay there, 169. Okay, that's not bad. But we only have partial voltage on the radio, so we're going to give it a lot more. Boom! Is it going to pop? The radio's come on. Whoops. 183. Hot diggity dog. Fantastic. Okay, we're good. We're good. Now, the fact is, I have to go to Costco and do some shopping. So I got to stop at this point and do that. So I'm off to Costco. Okay, back from Costco. Now, why don't we go after these two guys right here? This one is connected to one of the IF cans here. There's a lot of parts going in here, wires. Looks like red wires coming here, so this is probably a B plus point. It's probably the primary of the transformer. And then it comes over to this tube. I believe this is a ground point here. So it's a grounded capacitor coming off of this IF. Now I've got a diagram here. So this is looking from the top. So in front, there's the transformer down here. So we're up in this. So we're in this area here. So here it is. Second IF. Where's the first? First. The first is a little bit in line with the transformer. There it is. And this is the second. Second IF. What big capacitor is connected to the second IF? Thanks for walking on the keyboard there, Cat. Okay, let's take a look. Second IF. This one here. The primary side, I think there's a big capacitor. This goes onto a line that goes all over the place. All over the place. Let's start over again. I think it's here. That one. That's another. I thought I did that one.